All right, guys, good evening once again. Happy to be back and happy to see you guys out. Numbers are still small, but I hope as we go along, more persons will turn up. All right, now, anybody remember what the procedure or what are the steps in carrying out this kind of factorizing this kind of expression? Now, what do we notice about these expressions? Generally, when we have four-term expressions, we generally take the approach first to see whether or not we can isolate pairs of terms that have common factors. And if we are able to do that, then we can use the method of factorizing by grouping. And so what we would have done, so I can just quickly look back on question one here. We would have examined the first pair and look to see if we have any common factor. Any of these letters are they common? So obviously we are not seeing any for the first pair. We'll look at the second pair, looking to see if we have any common factor. We're not seeing any for the second pair. But when we look at the terms in the expression, we can rearrange terms so that we get pairs with common factor. So in that case where we are not able to immediately notice pairs with common factor, we may rearrange the expression so that we can put those terms that have the same factors or common factors together. So for instance, we see that we have AX here, we have BX. So what is common to these two terms would be the X. So the X's are common, so we could pair those together. So we could write AX plus BX as our first pair. And then now we look at the next two. So we see we have BY and AY. So those also could be grouped based on the fact that they have Y common. But we want to arrange it so that we have it in a similar order as the ones with the X. So we're going to have AY first. So we're going to put AY followed by BY. So once we have rearranged the terms, now we have them in the form where we have common factors for each pair. So we have AY, then we are going to put plus BY. All right, so next, what we do now is that we isolate the pairs. So the first pair here would be the first two terms. And so we pick out the common factor. And by referring to it as common factor, we really mean the HCF. All right. So common factor in this case really means HCF. All right, so we take out what is common for the first pair, which is obviously the X. So each term here, we are going to divide by the HCF. So we say AX divided by HCF, the X cancel, leaving A. So we just put the A in the brackets. Now, we're factorizing this pair, so the plus sign between them, we keep the plus sign in the bracket. And then we divide the next term, which is BX by X. So I divide BX by X, the X cancel, leaving B. And then we close that bracket. Now, moving on to the next pair, we need to keep the plus sign in the middle here. And then now for the next pair, we pick out what is common. And what is common in the next pair here would be the y. So we are going to pick out y as our HCF. Then we divide each of these terms in the second pair here. So y into ay, the y's cancel, leaving a. So we're going to now put a, open the bracket, put a, and then now keep the plus sign between them. Then now we say y into by, y's cancel again, leave b. So we put b in the bracket, then we close that second bracket. Now at this point, we want to ensure that when we look at these two brackets, the expression in them are the same. Now, if the expression in them are the same, we're going to continue to factorize using those expressions as a common factor. If the expressions are not the same, so suppose instead of getting a plus b in one of the brackets, you might get a minus b. So in that case, there would not be the same expression. So in order to really continue to factorize, we have to somewhat either go back to from the beginning, try to do a new arrangement, see if when we reach the second step, we can get the brackets to be exactly the same expressions. And from that point on, once we have the brackets as the same expression, now we're going to treat the brackets as a factor, but not just as a factor, but as a HCF. So we pull out the brackets as an HCF because it is common for each of those terms. So we pull out the bracket a plus b, close the brackets. Now, as before, we're going to open our brackets. Now, each of these terms, so this is a term by itself, and we're going to divide that term by the expression a plus b. Now, when we divide this expression, this term here, xa plus b, the a plus b going to cancel out, leaving just x. So if the a plus b cancel out, we leave with x, so we put x here in the second bracket. And then now we keep the sign, the plus sign in the middle here. And then now we divide the next term, which is y bracket a plus b. So we're dividing y bracket a plus b by a plus b. We see that the a plus b's cancel out. So the expression a plus b cancel out, leaving the y. So we just put the y here, and then we close that bracket. And now what we have remaining here now would be our factors that we would have gotten from factorizing that expression. All right, now it is important to remember that factorization is just a reversal of when you're multiplying out brackets. So when you multiply out the brackets, or when you find a binomial product, you will oftentimes get a four-term expression. And so you should be able to work back from that four-term expression, go back to the bracket. So that's why we say that factorization is reversing when we're finding product of binomials. Let me see the hands of those who are clear and understanding exactly what I'm saying.
Sir, for the a plus b,
Right.
we should keep the a plus b, or it's the x plus the y the answer?
No, man, the a plus b has to be kept to as well, because that would be a factor.
Okay, sir.
When we talk about factors, we talk about things that are multiplying together. So if you take away the a plus b, you're only going to left with an expression by itself, which is just x plus y. But that expression in bracket is treated as a single unit. So the x plus y in brackets is a single unit. The a plus b in brackets is a single unit. And so when we bring them together like this, what we're doing is really multiplying them. So we are saying that a plus b in brackets is one factor multiplying by x plus y in brackets as another factor. You get what I'm saying? So just like
Yes, sir.
have factors with numbers, so we say 2 times 3, right? These are two factors. If we multiply them out, we get the product, which would be this with 6, all right? Now, in a similar way, if we multiply out back these brackets, we should be able to get back what we started off with, because this is actually the product when we multiply back the brackets. And we can go ahead and just check that. So we can multiply out this bracket by the distributive law. So it's a times x, we get ax. And then now using a again with the y, so we have a times y, keep the plus sign. So we have ay. And now we use the b now, distributing the b. So b times x give you bx, that's plus bx. And then now we have b times y, will just give you by. So b times y now give you by. So we have plus by. Now, when you look at all these terms that we just multiply out, you'll notice that they're all the same term that was given in the 4-term expression here, right? The order in which they appear doesn't matter. Once you have the exact same term in the expression, it means then it would have been the product, right, from removing the brackets. So by multiplying out, we are finding the product. That means you're multiplying the first bracket by the second bracket using the law of the distributive law to do that. And so when we have done that, we would have gotten this expression. And if you look up here, you notice that you have the ax, you have the ay, you have the bx, and you have the by. So all of these are in this expression. So it means that once you have all the same term, when you multiply them out back, it means that your factors would be correct. All right. So factorizing really means that we are given a product and we're writing them back into factor form, right? Clear now, Miss? Should be abundantly clear. Anything, any other question? Are you good now, Miss Travia?
Yes, sir.
All right, anybody else? All right, so all that we've been doing is to isolate pairs with common factors. We factorize each pair, and when we get our bracketed expression, they must have the same expression in them. And so we continue to factorize by those brackets to get the full or complete factorization. So let us try the second one here, which we would have done too as well. So if you look at this pair, the common factor would be p, because p is common in both terms. Now, so it means that we can factorize this pair by using p as the HCF. So using p as the HCF, so we pull out our p, and now we open our bracket, divide each of these terms by p. So if you divide MP by P, the P's cancel out, leaving M. So you put the M here in the bracket, and then you keep the plus sign. Now you divide NP by P, divide NP by P, the P's cancel out, leaving N. So you're left with in the bracket n plus n. Now we look at this sign here, it's a minus. Now, sometimes this minus here can be a little tricky because oftentimes you might forget that we are working with a minus and instead put a plus sign here. And that can lead us on the wrong path. So pay attention to the sign when we are doing the next pair. So the next pair here is a negative. So we are going to choose our common factor to be Q, but not just positive Q, but negative Q. And so by doing that, we now can divide all of this, which is negative MQ, by a negative Q, and then divide a negative by a negative. The result is what? What sign? The result must be what? Positive, right? So you would have a positive M when you divide negative MQ. And when you divide negative NQ, you're going to have a positive N. Now, if you notice now, that will be important in order to get these two expressions to be the same. All right, because that's what we really want when we're factorizing this. We want these two expressions to be the same so that we can continue factorizing using this expression as our HCF now. So we just pull out the bracket as the next common factor for the entire expression. So we pull out m plus n, close our bracket. So this is our common factor now. Now we are going to divide. We're going to divide p bracket m plus n by m plus n. So the m plus n going to cancel, the expression going to cancel. This will cancel with this, right? Once that those cancel, now we are only left with the p, so we put the p there. And then now we use m plus n to divide this side, m plus n cancel, leaving only negative q. So I put negative q in the bracket here. All right, so after we write this q, then we close our bracket. So these are our factors. All right, now, sometimes once you identify the two brackets, you will notice that the second brackets from here, the common bracket would be m plus n. But what you notice here is that for the second bracket here is what really outside we put back in the second bracket. We put back the p and we put back the minus q in the second bracket. So you can also look at it in that respect. So once you have these two brackets that are exactly the same, you just take what is outside the two brackets and put it in the second bracket. All right, so some of you might be able to see it like that. So let me see your hands if you're all on board with me and everybody is following clearly and know exactly what to do. Let me see your hands, guys, if you're following. All right, some persons are still a little reluctant, so they're not quite sure. So for question 3, we're pretty much following the same general trend, looking for common factor. Anybody can tell me now what would be the common factor here for this first pair? What is a common factor? Anybody? Come on, man.
Sir, AC.
AC would be common. So we pull out the AC as our factor. So we are factorizing using AC as HCF. So AC into AC square. So you know that when you square a letter, it means you're multiplying it by itself. That means you're going to have two A's multiplying together here. So when you divide, one of the A going to cancel with the one of the A that is in here. So you're going to have A squared divided by A, going to leave back an A. And C squared divided by C, going to leave back a C. So what we'll put in the bracket here now is just simply AC. Then now we go on to the second term and we divide the second term by AC. When I divide ACD by AC, what you get? Come guys.
D.
D. So you would put D in the and close this bracket. So that would have completed factorizing the first pair. For the second pair now, what would be common?
E, sir.
D.
D. All right, remember to put back our plus sign in the middle. This is the plus sign that is in the middle. We have to put back that sign. So we find the common factor here, which is D. And remember, when I say common factor, I mean HCF. All right, so D is common in this pair. So when we take D to divide each of those terms for AC, we're going to divide that by D. The D's cancel, leaving what?
AC.
AC. So we have AC in the bracket here, the plus sign that we have here. And now we say now D into D square. Square will just leave you with one D. You close the bracket. Now, what did I say about this stage? Once the two expressions in bracket are the same,
You just
pull out that expression. As your common factor. Now, what you have outside the two brackets, you have AC and you have plus D. So these are what we're putting in the second bracket. So you put AC plus D. Now, so these would be the factors. What happened though, it turned out that these two factors are exactly the same. And because they are exactly the same, it means that you have a bracket multiplying by itself. And when you have anything multiplying by itself, what you do is square it. So this really is the same as saying AC plus E all square. All right, so that's what it would work out to. Any question, guys? Everybody see how we get here? Everybody following so far, right?
Yes, sir.
Okay. All right. So let me see the hands of those who have actually completed this exercise and did all the questions. All right. So one person actually did. All right. So let us look at question 4. Let me just go through them because we don't have all evening to work these. So we have question 4. We have 2PR. Matter of fact, we can just look at the question and pull out what is common for the first pair. What is common for the first pair?
P, sir.
All right, so note that for the numbers, you need to find the highest common factor, which is the highest number that can divide both the numbers. The highest number that can divide 2 and 4 will be 2. So your HCF for the number will be 2. For the letters, you just choose the common letters with the powers. If you have more than one or different powers of the same letter, you choose the one with the lowest power. So here, both P's have the same power, so you just choose a P. All right, so those are the two common factors for the first pair. So we factorize by the 2P. So divide each of these terms by 2P. So the first term divided by 2P, we have the P, the 2P's cancel, leaving R. So we put R in the brackets. The second term, 4PS, 2 into 4 goes 2. So when I divide 4 by the HCF, which is the 2, you get 2, and the